Hello guys, in this video I'm gonna shed light on basically lab 1, which is how to simulate a logic circuit in multisim. Okay, so you are given an equation, a Boolean equation, Boolean expression, and there are 4 parts in that lab. Okay, I'm gonna highlight only part 2, which is the amazing part here, like the most interesting one actually. Okay, so in part 2, it asked you basically to simplify the Boolean expression given, and based on that, simplification, it asked you to build a circuit to verify like part 1. Okay, in part 1, basically, you're gonna implement that equation here in multisim. Okay, okay, how many gates in that equation? Let's assume like you can use like a 3 input AND or OR gates. So let's count how many gates you're gonna have. So you have the AND gate here between A and B. You have the AND gate between A, B bar and C plus BD, the expression C plus BD. You have an OR gate. You have another AND gate here. Okay, we have an OR gate. You have AND gate between A bar, B bar, and you have AND gate between C and all that expression together. So how many gates here? You have 1, 2, 3, 4, 5, 6, 7, 7 gates. 7 gates. Assuming that you can have like more than 2 input or AND gate. Okay. So here comes, the beauty of the theorems and the axioms that we studied. Okay, because based on these axioms and the Boolean algebra theorems, you can simplify that expression and you can implement it using much less gates. Okay, let's see how to simplify that. Okay, so we are given here this expression AB bar. Let's remove this. Okay, you have expression here AB bar C plus or plus is or BD plus A bar B bar and all ended with C. By the way, we usually don't count the invert. That's why I just counted the and or. Okay, so for some reason, of course, we do that, but it's not our topic now. Basically, because most of our circuits are sequential circuits. We're gonna study this like later in the course. And in sequential circuits, you're gonna get like the inverter for free. So that's why we don't count the inverted signal, okay, or the inverters. Okay. So let's see how to do that. So I'm gonna first take the AB bar and distribute it on the C plus BD. So we're gonna have X equal to A B bar C plus A B bar B D plus A bar B bar. All of that is ended with C. Good. Remember that B bar is equal to 0. Okay, when you end a signal with its inversion, the output here is always 0. Let's do that. Let's see. So you have here B bar. B can be 1 or 0. So B bar will be just as a complement, 0 and 1. So let's see. Let's call this output Y. So 0 and 1 is 0, 0 and 1 is 0. So the output is always 0. So basically that term here will be vanished, will be 0 all the time. So that will be equal to, or reduced to, A B bar C plus A bar B bar, and all of that is ended with C. Let's now distribute C on that equation. So that will be A B bar C C plus A bar B bar C. Remember again, C ended with itself will give you C. Okay, C ended with, again, you can do that, C and C, 1 0 1 0. Y will be 1 and 1 is 1, 0 and 0 is 0. This is basically C, 1 0, right? So when you end the signal with itself, the output will be itself. So that can be reduced to A B bar C plus A bar, B bar, C. Let's now take B bar C as a common factor. So B bar C, and we're gonna end up with A or A bar. You can do it. A plus A bar is 1. How? Let's do that. A plus A bar. Let's call the output Y. So basically you're gonna have OR gate here, and the two inputs, I'm sorry, this is ended. So one input is A bar, the other input is A. This is A, this is A bar. A can be 1 or 0. So A bar will be 0, 1. 1 or 0 is 1, 0 or 1 is again 1, right? So when you OR a signal, a digital signal or a binary signal with its complement, the output will be 1 all the time. So that will be reduced to B bar C. And 1, of course, be anything ended 1 is the same thing. So this whole expression with 7 like gates will end up B bar C. How many gates here? Just 1. So that's basically just 1 gate, B bar C. Again, we don't count the inverter. If you count it, it's okay. But again, we have here more inverters than here. Okay, so we have here 3, so it will be all over like 9 gates, because you need an inverter for the A, an inverter for the B. So we have 7 originally, so this is 9. So here we're gonna have 2. Let's assume we have any expression, and you wanna and you simplify this expression, and you wanna be sure that your answer is correct or optimal, because you might simplify it, but not to the most simplified like version of it. Okay, so there is a website, actually many websites, many online calculators that can simplify Boolean algebra for you or Boolean expression for you. So I'm gonna share with you one of them. I'm gonna leave the link in the description here. So that this is one of them, okay? And it has already because I already put the equations there. But anyways, if you wanna use it, okay, you can just write it. Like for example, if you wanna write the C, here is C, just caps lock and the C. You know, if you wanna write the inverter, let's for example remove this B bar. Okay, let's remove it. So to write inverter of any signal, a complement of any signal, shift, do the exclamation mark. So shift 1, number 1 is basically exclamation mark and also number 1. So you do shift and press 1 while you're holding the shift. This will give you the bar. Okay, now you write under the bar, so you're gonna write B, Control B, and here it is. Okay, so that's very easy. Okay, guys, so I already did it. You just hit go after finishing, and as you see, the output is B bar C, just like what we did. Okay, it's very easy, right? Very extremely easy. So and it also gives you the various steps. Okay, and I encourage you to do that. I encourage you to use this website. Okay, we are now like in a world like we don't do manual work. You should understand, of course, okay, but to be more productive, use these calculators. Okay, I advise you in this course to do first like by your hand, and then verify your answer using these calculators. Okay, so here all the steps that this website did to reach B bar C. Actually, our solution is much shorter. Okay, so I'm gonna leave this to you. You can check this and verify it's correct. It's of course correct.